So again, what we're asking, the question I'm asking is, what is an antiderivative on the problem we have on this screen? Again, this is indicating that we're going to take the integral of, the indefinite integral of, and this piece right here, the integrand, is the derivative. When we solve that problem, do the work we need to do, we create this. And this then is the original function. So if we take the derivative of this, what should we get? Yeah, we should get this. Okay? So the antiderivative is the original function. The integral is the process, more or less. It is the, well, I'll just call it process. Of taking the derivative and going back to the function. So in a way, it's kind of like the inverse functions in a way. We start with the answer and go back to the original question. It's not an inverse because I'm not truly solving for the input, and that's what we usually do on inverse functions. Okay. So we stopped with this one, and when we have these problems to solve the differential equation, what we're asking is, what is the original function? We're given information on the second derivative, and then we're given a specific value for the first derivative when we know 0 is the input in this case. And then we also know, good morning. We also know a point on the original function, but we are not given the original function. So we have to solve this. So the first thing we do, and this is the second derivative, if I take the integral of the second derivative, what is the result of that? First derivative, yeah. So we're going to take the integral of sine x, and again, always remember, this is the second derivative, but I've got to tell it what the input variable is. And how do I tell it? Yeah, I use the differential dx. Okay. Now, if you want, let's just put some notes down because we haven't seen these types of problems before. This is the first derivative, and when I solve this, what am I going to get over here? I'm sorry, this is the second derivative. When I solve this, what will I get? Yeah, first derivative. Kind of gave that answer away, didn't I? Okay. So I'm going to get the first derivative. That's what my answer is going to be. Will I use a different process than I have? No. It's a function. Second derivative is a function. First derivative is a function. This one happens to be the derivative of this one, so we're just going to work it as we would before. So now we just have to think backwards. What function has a derivative of sine x? Yeah, we might like to say cosine, but remember the derivative of cosine is negative sine x, so this would have to be, yeah, negative cosine x. Am I done? Yeah, I've got to have that constant of integration because there's infinitely many functions, remember, that would have the same derivative, varying only with this constant value here. Okay, so this is my first derivative. Now, what information do I know about the first derivative? Yeah, Emma? So if I say, the first derivative is negative cosine x plus c, but as Emma has reminded us, if I know that f of 0 equals 1, that means that negative cosine of 0 plus c also equals 1. What's the cosine of 0? So the cosine of 0 is 1, okay? So this is 1 equals negative 1 plus c, so what is that constant of integration? 2. So now that I know that, can I write that first derivative definitively? Absolutely, I know what it is now, and Lindsay, read it off for us. Plus 2. Okay, so plus 2. Now, if this is my first derivative, and what I'm really trying to find is the original function that creates this first derivative, what do I need to do? Yeah, take the integral of, remember the parentheses are extremely important. If I don't have the parentheses there, I am only taking the derivative of negative cosine x, computing that, and to that answer adding 2. Isn't the same thing as having that whole integrand. And then we have dx. Okay, so once again, we need to think backwards on this. What function yields a derivative of cosine? Sine, and because the derivative of sine is cosine, we have a negative, which this is going to have to be negative sine x, okay, plus, how are we going to treat that 2? Yeah, well, actually, it's 2x to the 0 power over here, so to show work, we would then say the exponent becomes, remember, we reverse the order in which we do things, and we reverse the operation that we're doing. So we're going to first add 1 to the exponent and then divide by the new exponent. Am I done? No. I've got it. Yeah, again, I'm going to have to add some constant there. So this now, all of this now, is what? Yeah. Yeah, Becca?
I understand why.
Okay, well, let's go. Absolutely, but we want to know what function yields cosine as a derivative. Okay, that's why we have to go backwards in our thinking on this. Okay, so now what we have is f of x equals negative sine x plus 2x plus c. Okay, but we know something about the function. Okay, what do we know about the function? Okay, so f of 0 equals 6, so that's the same thing as negative sine x plus, whoops, negative sine times 0 plus 2 times 0 plus c. Well, again, thinking about our unit circle, what is sine of 0 radians? Or 0 degrees, either one, 0. And so I end up with 6 equals 0 plus 0 plus c. So now the last step then is to write, because this is called solving the differential equation. What is the function that yields that second derivative? And it would be negative sine x plus 2x plus 6. Okay? That's the process, solving the differential equation. Okay, let's go on. Here now is one of those word problems that we're going to do a little bit of thinking about. A of t is acceleration. So let's just put that in right now. This is acceleration. Okay. Acceleration is the derivative of what? Velocity. And velocity is the derivative of position. Okay. So what we actually have is the second derivative. So a of t is the second derivative of the position function. Let me put another step in here, though. It is the derivative of velocity, which makes it the second derivative of the position function. Okay, that's what acceleration is. So what we're given is the acceleration is negative 9.8 meters per second. Show that the height above the ground of an object thrown upward from a point S sub 0, this is the initial position that we are when we throw this object up, with an initial velocity of v sub 0. So we're going to either just let it go, or we're going to really toss it as we're letting it go, is given by this function. Okay, so we're going to show this is true. Now, we have traditionally in this book used S for this, and so we could go back and say, well, this is S of t. Okay, for whatever reason, the book chose this problem to put F of t, so we'll make it S of t. So how will we approach this problem, given this information up here? Let me ask this question. How different is it from here? This one said solve the differential equation. We were given the second derivative, okay, and asked to go to the original function. What are we given here? Second derivative, and we're asked to go to the original function to show this is true. Okay, so it's basically the same problem. So the first thing would be to take the integral of negative 9.8. Do we have a variable with that? Okay, but the acceleration is negative 9.8. The meters per second is just the units. And so this would be negative 9.8. What's our variable? Okay, so we'd have to use the differential dt. So if I solve this, now again, this is our acceleration, which we define to be equivalent to all of those. When we solve this, we're going to have our what function? Yeah, we're going to have velocity when we solve this. So negative 9.8, what function would yield that derivative? Yeah, because we'd have t to the 0 over here, and we would just do our 0 plus 1 and divide by the new exponent, plus c. Okay, so we have negative 9.8t plus c. Now, it says, show that the height above the ground of an object thrown upward from a point s sub 0, an initial velocity of v sub 0. Let's see here. How can I help us get into that? What if we look at v of 0? V of 0 is the velocity at what? Time 0. What does v sub 0 stand for? At time 0, right? So this is the same thing, v sub 0. And that, if I use the same information I was using on the other problem, means that my acceleration, okay, so actually my velocity here, v of t, well, I'm already on the screen, I don't need to rewrite it, I guess. V sub 0 is, or v of 0 is v sub 0, and this is v of t up here. So this would be negative 9.8 times 0 plus c. So in other words, the initial velocity could be written as c, or I should say it this way. The constant is the same thing as the initial velocity. Okay, so that tells me that v of t is negative 9.8t plus what? I'm just making a substitution here. So plus the initial velocity. Now I don't know what that is. Okay, that's not something that I know what it is, but I have, I don't have to know, do I? I just want to show that I actually get that in my position function. So what's my next step? Yeah, take the integral of negative 9.8t plus v sub 0 with respect to what variable? with respect to t, which means we use the differential dt. Okay.